Good morning. It's probably not morning for you when you're watching this, but it's morning for me when I'm making it. This is just going to be a video on this following learning target. I mean, I could make a video for me doing the whole worksheet. I do have the whole worksheet here, but I'm just going to go step by step through each of the learning targets. So if you are wanting extra support with just this learning target about how to use variables and abstract situations, meaning how do we take things that are just for numbers and make them be broader using letters, then this is going to be the standard for you, and it's going to take me through the practical meaning of this stuff. So if you're looking for the other standards, click on the other videos. Okay, so for these magic numbers, we're just going to work column by column. Not every student does this. You can do it in lots of different ways, but I'm just going to go column by column, right? And I'm just going to follow whatever directions here. So it says start with a number. They told me to start with 4. So to get to this box here, I'm going to read the directions and says decrease the number by 6. So I know decrease means to subtract, and so I'm just going to subtract 6 from 4. So really what I'm doing in my brain is starting with 4 because that was what was in the box above, and then subtracting 6. So I can do my calculator, I can do my brain. 4 take away 4 would be nothing, so 4 take away 6 would take me to -2. And that's the answer in the box. And then to go a little lower, I'm going to follow these set of instructions. So I'm going to double the result, and the result meaning the box above it. So whenever it says double the result, you're going to what's in this box and doubling it, meaning making 2 of it. So if I had 2 -2s, I would end up with -4. All right, so same exact strategy for the other box. I wonder if it'll just let me do this. Yay. So follow the instructions, starting with -5. I'm going to decrease the number by 6, so subtract 6 takes me to -11. Double means multiply it by 2, or 2 copies of -11, which would give me -22. I'm not going to write 2 -11s because I don't go around telling people that I'm, 44 plus 3 years old. I go around telling people I'm 47, which I'm not. Okay, so then the last one's probably the trickiest because this is where the abstraction happens. Instead of starting with a random number, a quantity, I'm going to start with a placeholder for any number. I'm not sure what this number is. It could be 75. It could be -24. So since I don't know, I'm just going to let it be a placeholder for what I don't know, right? Because I can do that. I'm going to decrease that number by 6. So if I look at what I did here, I subtracted 6. I subtracted 6, so I need to subtract 6 from here as well, and all that means is I put a -6 behind the n. Now you might be wondering, is that the same thing as 6 minus n? Nope. I can prove it to you quantitatively. Is if I pretend n is some number, 6 minus 4, which is 2, is not the same thing as 4 minus 6. These quantities are not the same. All right, taking away 6 from something, which is what I'm doing here, is not the same thing as taking away some number from 6. So that's the reason why it's not 6 minus n. I'm going to start with the thing above it and then do this. All right, now it says to double the result. Now remember, I think I said this in class, but I'm saying it again here. The result means whatever is in that box. So I see 2 things in that box. I see an n, which I have to double. So now I have 2 n's, and I have to double that -6, or I have to double that 6 and bring the minus sign with it. So that's the correct answer from here. If you think about n minus 6 being doubled, I just have 2 copies of it, and now I have 2 n's, and I have my -12. So you can think about this visually, or you can think about this algebraically a little bit more by like just multiplying by 2, multiplying by 2. Either way, that's the correct answer from here. So now that's what should be in the box. I hope that makes sense. We'll do a couple more here just because I know that these are also sometimes tricky for kids. 5 less than the product of a number n and 7. So that's a lot going on there, right? We had a discussion about the word and, how sometimes and can mean plus and sometimes and can mean times. So I never want to rely on the word and to figure out what I'm doing because it could be complicated, right? So I'm looking for other words, and those are the words I highlighted. Product, less to me means subtraction. Product means multiplication, right? So 5 less than a multiplication. So I know I'm subtracting something, but I have to multiply something first, because 5 less than what to multiply. Nobody told me what to multiply, so I got to go further in the statement. That's why I can't just write like 5 minus, which by the way, that's not correct either, but we'll come back to that in a second. So if it says 5 less than the product, I have to figure out what the product is first before I put that minus sign in there. So naturally, I think if you keep going, it makes sense that we're putting together 7 and n, and we write the product as 7n, because when you're missing a symbol in the middle, it's automatically a times. If you just write them like this, obviously now we don't have a product, you have a sum, so 7n is just 7 with the n, because the times is kind of hiding in there. Okay, so now we've got the product of 7 and n, that's this. Now we need 5 less than that. So 5 less than, and again, if you remember what we talked about in class, less than means put the 5 behind the 7n. Why? Well, if I said to you, what's 5 less than 8? If I just said, think of a number that's 5 smaller than 8. That's what less than means, right? 5 smaller than 8, that's 3. A number that's 5 less than 8 is 3. So if you do the order that you see it, 5 minus 8 does not get you 3. So you can't have some sort of logic and then have some sort of statement and them not match up. So either your logic is wrong or this little equation that we've written is wrong. 5 less than 8 definitely is 3. So if our logic is sound, then 5 minus 8 can't be it. So how else do we get 8? I'm sorry, how else do we get 3 from 5 and 8? You have to reverse the order, right? So it's 8 minus 5. So those statements of 5 less means that we're going to put the less than symbol in the back. So 5 less means the minus 5 goes in the back. 5 less than what? The product of n and 7. So I'll put the 7 and the n minus 5 in the front. And that's how I ended up with my answer. Okay, hopefully that's a little more clear. All right, last one. And again, hopefully you feel free to like skip around all these videos. So I know you guys know how the internet and, you know, YouTube watching works. So I'm assuming you're doing the same strategy here. Okay, practical meaning, I've got some variables, meaning I've got some letters that stand for things. So G is the number of Girl Scouts. L is the number of Girl Scout leaders. C is the number of cookies. P is the price of a box of cookies. So we've got a lot going on. Notice I color-coded G and L as the same color because they're kind of measuring the same thing, but not really. G is the number of Girl Scouts. L is the number of Girl Scout leaders. So now they want me to figure out what's the practical meaning of G plus L. So again, here's what we're absolutely not going to do. It's the number of Girl Scouts plus the number of Girl Scout leaders. Now, that can be your work. That's not a wrong statement. You're not wrong, but you're not answering the question. So if I said, what's the practical meaning? All you did was translate what the letters were with words, okay? But I'm looking for one step further. I mean, I'm looking for you to explain what would happen if we did that. So if we take the number of Girl Scouts, so let's make a number up. If we take the number of Girl Scouts, let's just say there's 70 Girl Scouts. And we plus it, so we add it to the number of Girl Scout leaders. So let's make up a number for that. Let's just say there are 8 Girl Scout leaders. Explain to me the meaning of 78. What's 78 represent? And I think 78, and if you want to pause here to just pretend like you're going to come up with an answer, this would be a good time to do it. So pause for a second. So to me, 78 is the number of people in, I don't know, in the Scouts or in the Girl Scouts or in the troop. I don't know anything about Girl Scouts, so I don't know. The number of people. I would totally accept the total number of people. You don't even have to go a little bit further. Number of people in the organization, whatever you want to say, all right? But it's the total, and actually to be even more clear, total is a great word to introduce there, okay? All right, one last one. I hope this video is like not 9 minutes long. What's the practical meaning of the expression P plus L? So P stands for the price of a box of cookies plus L, which is the number of Girl Scout leaders. Okay, again, we're not going to translate, but that does kind of help me think through what it's saying. So if I take the price of a box of cookies, I don't know, $6.99, I have no idea. And you add it to the number of Girl Scout leaders. I don't know, let's say just say there's 10 Girl Scout leaders, because it could be any number you want. 10 Girl Scout leaders plus $6.99. I have absolutely no idea what that means. $16.99, if we added those numbers together, that's not the price of anything. I can't add one cost of a box of cookies and add it to 10 Girl Scout leaders. If there were 10 people in our room and I said, hey, I just went to Jewel and spent $6.99, let's add it to the number of people that are in here. No, like, why? You'd be like, why? Right? There's no reason to do this. So the practical meaning is none. These things don't go together. I can put different letters together. I did that up here. See, these were different letters, but they represented sort of the same thing. See, that's why I color coded them. G and L represent sort of the same thing. So we can take different letters and make meaning out of them. Sometimes we put letters together and it has no meaning. And again, the letters don't have to match. I can put C and P together too. If I multiply C times P, C is the number of cookies I ordered. Let's just say I ordered 10 cookies, or 10 boxes, whatever. P is the price of one box. Let's just say that's $5, right? So if I multiply C times P, I get 50, and 50 is going to be the number of money I spent on the 10 boxes, right? So C and P can go together, G and L can go together, and P and L can't. So there's sometimes we can do weird things with letters, and sometimes we can't. And it's going to be your job to figure out when and where. All right? That's your Learning 1-1 refresher. Hopefully that helped.